Okay, so this is the first run through of some multi-choice questions. So we're going to look at the 2011 exam. As you'll see, I've got up here the Casio ClassPad 2. So this is the latest model. If you're working off a different one, hopefully you'll be able to adapt what I do to your device. So everything should be fairly similar. Okay, so let's have a look at the first of 22 questions. The midpoint of the line segment joining 0, -5 to D0. If you know the formula for midpoint of a line, the x-coordinate will be halfway between 0 and D, which is D on 2. Now, that's pretty much all you had to do. You could work out what the y-coordinate was of the midpoint, but there's no point, because as you can see, D on 2 is the only A is the only option that has D on 2 as the x-coordinate. So move on, circle it. Again, I've put the percentages here of the people that got it right, where if it's interesting, I'll show you some common incorrect answers. Alright, like in this one. We've got the gradient of a line perpendicular to the line which passes through -2, 0 and 0, -4. So the gradient of this line would be -2, so the perpendicular line would be 1/2. So turn it upside down and get rid of the negative, gives you 1/2, which is A. You'll see a lot of people thought that it was C. Question 3, we have if x plus A is a factor of this, where A is a real number, not 0, then what's the value of A? So I'll do this one on the calculator. So if x plus A is a factor, that means that if I sub -A into here, then that should be equal to 0. So that's what I'm going to do. So I'm going to, let's see. Okay, so I will sub in -A, so I'll just type that in, 4 times negative. Now I'm going to use Y instead of A here, just so it saves me going into the keyboard. Minus 13y -y squared minus y times -y. It's always good to use lots of brackets just to make sure. Okay, so if I set that equal to 0 and solve, with respect to y, whoops, so I'll do comma y, I get -3 or 0. Now we know that A can't be 0, so the answer is -3, so B. Alrighty, question 4. The derivative of log of 2f of x with respect to x is. So with this one, to differentiate that, it doesn't matter what f of x is. Let's just say, for example, it was x. In order to differentiate that, you'd use the chain rule. So to differentiate what's inside the brackets, 2 times f of x would be 2 times f dash of x, and then you would have multiplied by 1 on 2f of x. So it's kind of hard to picture without using a function for f of x, but you could actually do that. Just let f of x be x squared or something like that and see what you get. But you get this, and those 2's are going to cancel, so leaving you with f dash of x over f of x, which is A. So 52% got that right. Alright, question 5, classic inverse question. So we want to know what the inverse of this function is. So the rule for the function is the square root of 2x minus 4. You could quickly just sketch that. Alright, and you should be able to see that the range of that function is 0 to infinity. And if you didn't know what it looked like, you'd always just quickly sketch it on your calculator. But the rule for the inverse, if we switch x and y around, you should be able to do this in your head. You should be able to get that it's x squared plus 4 on 2. Okay, and the domain of the inverse is the range of the original function, so that's how we got D. So the inverse of the domain of the inverse is 0 to infinity, and the rule is x squared plus 4 on 2. At the very least, you should be able to narrow it down to A, D, or E, and the clever people would have gotten that the domain was 0 to infinity. Okay, so moving on, we have a continuous random variable PDF log of x from 1 to e. We want to know the expected value. So if you know your expected value formula, you'll go straight onto your calculator, get up a integral sign, and we'll integrate from e, just e to the power of 1, to 1, and then instead of a log of x, it will be x times log. Now log e is ln, so just use ln, it's quicker. Okay, and that gives you, let's change it to a decimal, it gives you 2.097, which of course is e. Easy one. Okay, moving on, question 7, linear approximation question. So considering the point 82 on the graph of the cube root of x, using the linear approximation method, they give you the formula here. Find an estimate for the cube root of 8.5. So what you need to do is sub 8 into the function, the cube root of x, and sub 8 into the derivative, and multiply that by h. And h in this case would be 0.5 because we're approximating 8.5 from the point 8. So I've just done the derivative by hand to save me a bit of time in the calculator. The derivative of the cube root of x is 1/3 x to the negative 2 on 3. Then if I use my calculator, instead of cube root, I'll use to the power of 1 on 3. So we've got 8 to the power, I don't know why I put that in brackets, but whatever. 8 to the power of 1 on 3. Make sure you put the 1 on 3 in brackets, that's important. Plus 0.5 multiplied by 1 on 3 times 8 to the power of negative 2/3. Okay, again, I'm using lots of brackets. I just think it's a good idea, even if you don't always need them. So there's the answer, 2.04167, which was C. Okay, moving on, question 8. It's a bit of a tricky one. Consider this function here, x minus 4, which is a quadratic, and this function here, x plus 3, which is a straight line, but we're only graphing it from 3 on 2 to 5. If the function h is equal to f plus g, then what's the domain of the inverse function of h? So sums and products of functions would tell you that if you want the h is just going to be f plus g of h, which is x minus 4 plus x plus 3. So that's the function there. Now the domain of that function there is the intersection of the two domains of f and g. Now the domain of f is R, so the intersection of the two is just going to be the same as the domain of g. So we're only interested in this function from 3 on 2 to 5. So basically I want to know, if I want to know the inverse function of h, what the domain is, then I'm really interested in what is the range of this function here. So I'm just going to sketch it. X minus 4 plus x plus 3. And I'm going to hit the graph button, drag it on, resize. My window's pretty okay at the moment. So let's have a look. We're interested in the point 3 on 2 to 5. Now, if you have a look, there's 5. That's going to be the maximum of the range, or the domain of the inverse. Now we've got a turning point somewhere. I'm just going to check where that turning point is, and it's at 3 on 2. So therefore, the range of h is going to be from 0.75 to let's do a y cal, and to 13. So my range of h is 0.75 to 13. So the domain of the inverse is 0.75 to 13. And if we were confused about whether or not we need a square bracket or a curly bracket, it actually doesn't matter because there's only one that has 3/4 and 13. So the brackets are irrelevant. Moving on, question 9. This is a fairly easy one. Could maybe do this one in reading time. So here's a function. What does the graph of the derivative function look like? So here's a stationary point. Here's a stationary point. On the derivative, those 2 points will be x-intercepts. So if we have a look at which of the 5 have a x-intercept at 3 and 0, there's this one. B, C, or D are the only options. Probably not C because we've got an extra intercept over here. So it looks like it's going to be B, because if we look at what happens, here's my stationary point here. To the left of this point here, we have a positive gradient, and the only place that happens is in B, so we're not fussed about the rest. It's B. Most people got that right. Question 10. Maria is a very enthusiastic young tennis player who plays a match every day. So if she wins on one day, there's a 0.8 chance that she'll win the next day, but if she loses, there's a 0.6 chance that she'll lose the following day. So long-term probability, we're looking at Markov chains here, and we're looking for the steady state solution. So there's a couple ways to go about it. Probably the easiest way is to use the steady state formula. So if you can quickly draw up your transition matrix, which would give you 0.8, 0.2, 0.4, 0.6, the steady state formula for a win would be this over this plus this. So 0.4 over 0.6, which is 2/3, so it's C. Okay, of course you could also raise it to a high power, but I'm sure you know how to do that. Alright, question 11. Average value of a function. If you know the formula for this, you'd be all good. So 1 over b minus a multiplied by the integral from a to b of the function. So b minus a is 3 minus 0, so it gives you 1 on 3 times the integral. So quickly do that on the calculator with a 3 and a 0. And I've forgotten the 1 on 3 out the front. I'll do that in a sec. X plus 2, close brackets, dx, and we'll multiply that by 1 on 3. And we should get the right answer. Oh, hold on. We want an exact answer here. 5 log 5 minus 2 log 2 minus 3 on 3, which is E. Alright, question 12. We've got a continuous random variable, the normal distribution of mean 30, standard deviation of 5. Now the probability that x is greater than a is 0.2. Correct to 2 decimal places, a is equal to what? We want to use the inverse normal function here. So I like to use interactive for this. Interactive distribution inverse normal. We want the tail setting as right and the probability as 0.2. And the standard deviation will be 5 and the mean will be 30. Push OK. And 34.208, which rounds to 34.21. Okay. Okay, question 13. In an orchard of 2,000 apple trees, it's found that 1,735 have a height greater than 2.8 meters. We don't know the mean, but we know the standard deviation is 0.2, so we want to work out the mean. So if 1,735 out of 2,000 have a height greater than 2.8, then that means that the probability of a tree having a height greater than 2.8 is 1,735 out of 200, and we can work out what that is as a decimal. So what we're going to do is we're going to compare this to the standard normal distribution. So we work out the z-score, in other words. So the probability that z is greater than, I've just called this little z, has to be equal to, the probability has to be equal to 1,735 on 2,000. So we could work out what 1,735 over 2,000 is if we like. Which is 0.8675. And then I might just copy that in case I forget. Okay, then we can go again to the inverse normal. and our tail setting is going to be right, and the probability is going to be, I knew I'd forget what it was. How do I paste? I can't remember, so I'm going to do 1735 divided by 2000. And the mean and standard deviation I'll leave as is, so that gives me negative 1.11465, and I'm going to plug that into the z-score formula. So I want to solve this for mu, and that will give me the mean. So action advanced solve. I probably might not need to use the solve function here, but couldn't hurt. 2.8 minus x over 0.2 is equal to, and then I'll drag this down so I've got a more exact answer. Solve for x, 3.023, which is A. Okay, question 14. Now a lot of people struggle with this one. We have a shaded area between two curves, and there's 4 different methods given here to find that shaded area, and we want to know which ones are correct. So if we look at the first one here is suggesting that we just integrate this curve here from 0 to 1. Of course, that would give me the area underneath that curve there, so that one's wrong. The second one is suggesting that I do e squared minus that area from the first part, and that would give me the right answer, because e squared would be the area of that rectangle there, 1 times e squared minus that, so that would give me the right answer. Okay, 3 is nonsense. 4 is actually correct as well, because this is used the inverse. So people that do specialist maths may have seen this before. Basically, if we find the inverse of e to the 2x, we get log e of x on 2. And if we integrate from 1 to e squared of the inverse, that will give me that area underneath that curve there. Okay, so 2 and 4 were correct. Now, if you had no idea about the inverse, I guess what you could have done is, if we knew that double I was right, we could type in e squared minus the integral from 1 to 0 of e to the 2x. So we could work out what that is and find that that is 4.19, and then what we could do is just go, okay, well, e to the e squared 1 of ln x on 2. If I work out what that is, it's the same thing. So therefore, this thing here, whether or not I know that that's using the inverse or not, I know that it gives me the right answer, so it must be right. So 2 and 4 are both correct, which gave you D, which is, as you can see, a lot of people put A because they recognise that this one was right, didn't consider that there could be something else going on. Okay, question 15. This one was easier than it looks. We've got a sine or cosine function here, and we want to know what could the equation be. So it says could because there'd be more than one answer here. So I'd look at the amplitude first. The amplitude is 2. So which ones have an amplitude of 2? So you've already narrowed it down to A, B, or E. So get rid of C and D. And the amplitude is 2, and the whole thing's been shifted up by 1. So that rules out E. So we're already down to A or B. Alright, so I'll look at the period next. The period would be the difference between pi on 6 and 2 pi on 3, which you can work out as pi on 2. So the period is pi on 2. This one has a period of 2 pi, so here's your answer. Must be B. Okay, 16 was a fairly tricky one if you don't like modulus functions, which not many people do. We're talking about this function here, so it's a bit better. So x squared minus 4, the modulus of that minus 2. Now if you're really good with your functions, you might be able to draw a quick sketch of it, which is what I've drawn here. So if you can't do that, maybe we can narrow it down somehow. Mind you, you can always just graph this. Alright, type that in your calculator and graph it, and then you should have a picture that looks like this. So continuous everywhere, yes it is. F of negative 2 is negative 2, yes it is. You can figure that out by subbing that in. Is the function greater than negative 2 for all values of x? That dotted line there is y equals negative 2, so yes. So it's got to be one of these two, and it's got to be one of these two. So the derivative is 2x for all x is greater than 0, or the derivative is 2x for all x is less than negative 2. Now, when you're finding the derivative of modulus functions, the bits where it's sort of the inequalities are at these funny bits here are where it changes. So the answer kind of had to be D, because at the point 0, there's really nothing funny going on here. I mean, it's sort of how you could look at it. If you know how to differentiate a modulus function, you'd figure out soon enough that it was E. But negative 2 is this point here where you've got this funny bit here where it changes between two different derivatives. So I guess that was another way, probably the easiest way to figure out what the answer was. So it was D. Moving on, question 17. The normal to the curve y equals x to the 3 on 2 plus x at the point 412 is parallel to which one of these lines? Now I'd just start by finding the equation of the normal of that function. So there's a nice method on your calculator for doing that. Interactive calculation line normal. Expression, type in x to the 3 on 2. Plus x. Variable is x, and we want to do that at the point 4. Don't have to put 412, just put 4. And the equation of the normal is negative x on 4 plus 13. So the equation of the normal is this. So the gradient of the normal is negative 1 on 4. So all I got to do is look at these graphs here and see which one has also got a gradient of negative 1 on 4. You should be able to see that it's this one here, 4y plus x equals 7. If you rearrange that into the form y equals mx plus c, you should get m is negative 1 on 4, whereas you don't get that with any of the rest. Okay, so nearly there. Question 18. This is a pretty tricky one. So the equation x cubed minus 9x squared plus 15x plus w equals 0 has only one solution for x. So that's asking you, if we set something equal to 0, we're finding the x-intercepts, aren't we? So I'm just going to, what I'm going to do, I'm going to graph this. Okay, and we'll see why in a minute. X cubed minus 9x squared plus 15x. So I'm going to graph that. Okay, I've got a minimum down here, so I'll just figure out what that is. It's at negative 25, so I'm going to change my window so that it goes down to negative 25. Maybe let's change this to negative 30. I'll leave the rest the same because it doesn't matter. Okay, so this function here, at the moment it has 3 x-intercepts. Now, if I was to look at what happens with w, if I've got a plus w, that means that depending on what w is, it's either going to move this graph up or it's going to move the whole thing down. So this point here, which was negative 25, if I remember correctly, if I was to move the whole graph up so that this minimum went above the x-axis, then I'd actually only have one x-intercept. So I would have one solution if w is greater than 25. So by the same logic, if I was to move the graph down so that this maximum point was below the x-axis, I'd also only have one x-intercept. So the maximum is at 1,7. So if I can get w to be less than negative 7, or W can be more than 25, then I'd only have one solution. So that's why the answer is D. Okay? Alright. So now we have a another area under the curve question. We've got two methods for finding the area under the curve. So one would give me the exact area, one would give me the approximate area. And we're going to see how much bigger is this approximation than the actual area. So the curve is y equals x squared. So basically just work out both answers. So the first one, I'm not going to bother doing this in the calculator, but if you integrate from 0 to 6 of x squared, you get 72. And if you do a right endpoint estimate, you get 91. So 91 divided by 72 is 1.26, I think, 1.2639. All right, so 91 is 126% of 72. So the area's gone up by 26%, which is closest to 25. So the answer is 25. Okay, moving on. So you'll notice the calculator is being cleared. That's because I mucked up the next question first time. So I'll show you what I did wrong, and maybe you'll learn from it. So we're looking at the graph x squared minus 4, and we're being told that these two areas here are the same. So you can work out that that point there would have to be 2, 0. Okay, so that means that if I integrate from 0 to 2 of x squared minus 4, it should be equal to the area when I integrate from 2 to a. So what I'll do is I'll start by working out what that first area is. So from 0 to 2 of the graph x squared minus 4. So if I work out what that is, I get negative 16 on 3. And if I integrate from 2 to a, so let's call it y, of x squared minus 4, what I get is y cubed on 3 minus 4y plus 16 on 3. So what I want to do is I want to set those two things equal to each other. And solve for y. And see if you've figured out where I've gone wrong. So I get that weird answer there. Alright, so what I've done wrong is I've forgotten to take into account that if these two areas are the same, well, I don't want the area to be negative 16 on 3. I want the area to be 16 on 3. So I've got to get rid of that negative. So that's better. The area has to be one of those three, A has to be one of those three things. So the answer was 2 root 3, which was E. Okay, two more questions. This video's gone for way longer than I thought it would, so sorry about that. Hopefully next one will be a bit quicker. Alright, interesting one here. We've got two events P and Q, and we're told that the intersection between P and Q is the same as the intersection between not P and Q. So P and Q will be independent exactly when. So I've drawn up a tree diagram, a Venn diagram. So here are my two events P and Q, and what we've been told in this little bit here is that this region here is the same as this region here. So I've called them both X. Now we know that two events are independent when the probability of one multiplied by the probability of the other is equal to the probability of the intersection between the two. So that means that the probability of P multiplied by this probability, the probability of Q, which is 2x, is equal to x. So if probability of P multiplied by 2x equals x, then that means that the probability of P is equal to x divided by 2x, which is a half. So it's actually E. Alright, this question was done really, really badly. I think people didn't really try to look at the algebra and had a guess. So I think all of the 5 options were pretty well spread out, but there you go, the answer was E. So final question, which was much easier than it looks. So this expression here, log CA plus log AB plus log BC is equal to what? Now the key was to just look at the change of base formula. So if you change the base of log CA, you change the base to A, you get log AA over log AC. And log AA is just 1, so it's 1 on log of C. And if you do the same thing, changing this base to B and changing this base to C, you actually get this one here. So the answer was B. Now, I guess another way you could do it was to maybe let A equal 1, B equal 2, and C equal 3, and just work out what that is, and then see which one's equivalent. But that'd take you probably a few minutes. So definitely the key here was to look at the change of base formula. So that's it. That's all 22 questions. Thanks for being patient. I know this is quite a long video. If you've got any questions, particularly about the calculator stuff, just leave a comment. I'm sure there were, with all 22 questions, there's always different ways to go about them. So I've just done the method that I think was the quickest. You may not agree. You might find something else easier. So totally up to you. Again, I recommend you look at the examiner's report for a better idea on how to go about some of these questions. So thanks for watching, and I'll probably do the 2012 multi-choice next, and we'll go from there. So thanks a lot.